Hi, it's Mrs. Hope, and today we're going to talk about common logs. These are logs with base 10. Our goal is to solve exponential equations using common logs, and we're going to use the change of base formula to evaluate log expressions. Key concept here, log base 10 is just equal to log. This is called the common log. It's the one that's most commonly used, and you will not see it written as log base 10. You just have to understand. If you just see log written without a base, understand that that means base 10. It's the common log. And when you see the log button on your calculator, that means log base 10. So you can't use that button unless it's log base 10. So keep that in mind. So what we're going to do is we're going to learn how to solve equations using logs. And that's the purpose of logs. Logs are used to undo exponents. So we don't know what x is. We know 4 to some power, don't know, is equal to 19. And everything else that we've used up to here to undo things, if we undo multiplication, we would divide. If we want to undo division, we would multiply. But if we want to undo addition, we'd subtract. Undo subtraction, we would add. But I can't divide by 4. That's not going to get that x out of the exponent place. So that's what a log is for. A log is going to help you bring down that exponent. And I'll show you how it works. So what we're going to do is take the log, this is what it's called, take the log of both sides. So the first thing is take log of both sides. So what I'm going to do is take log, and remember if I don't write 10, it's just log base 10. So log of 4 to the x is equal to log of 19. By taking the log of both sides, there's a power property that we can use. Power property is going to bring down that exponent. So now that I have the log, this means x log 4 is equal to log 19. Now we can isolate x just by dividing by log 4, divide by log 4, and you should have x. And because I use log base 10, you can use your calculator. So take your calculator, log 19 divided by log 4, and you should get something around about 2.1240. All right, moving on. Let's solve 3 to the x is equal to 15. We don't know what x is, and the way we're going to get rid of that, bring that down, is taking the log of both sides. So let's take log of 3 to the x is equal to log of 15. That allows me to use the power property. So x log 3 is equal to log 15. Divide by log 3. Divide by log 3. Now you can use your calculator. X should be about, I'll write this one down somewhere, 2.4650. I do not know that off the top of my head. Definitely use the calculator for that. So this is about approximately what you should get. Example 3, the change of base formula. What if the base is not 10? I've talked to you about common logs having a base of 10. Well, what if you don't have a base of 10? And it's going to happen often. You cannot use the log button on your calculator. So if you don't have base 10, don't use it. It's not going to work. It's not that I don't want you to use it. It's not going to work. It will be wrong. So the key concept here, log base a of n, and this is the change of base formula, log base b of n divided by log base b of a. Let's turn that into English. So if you have log base 3 of 11 and you want to evaluate that, you can't push the log button in your calculator. But you can take log of 11 and divide it by log of 3, and it will be your answer. Notice I didn't write base 10 here because I'm using base 10, and that's what the b is here. You could use any base, but you might as well just use log base 10 so you can use your calculator. So a shortcut to maybe remember, when you have log base 3 of 11 or something like this, it's the log of the big divided by the log of the little. The log of the bigger number divided by the log of the little number, the base. So let's try one. Log base 3 of 20. Let's evaluate it in terms of common log. So I want to know what this value is. I would need to put it in my calculator. Can't put it in my calculator. But if I use the change of base, I can. That means log of the big number divided by log of the little number. If you put that in your calculator, that's your answer. Should be about 1.1606. That's it. Thanks for watching today, and remember, you are responsible for your own learning.